Hello friends, I welcome you in lecture number 8 on applications of integration. In this lecture, we will discuss one more problem on the disk method. The new thing about this question is, in this question, we are going to consider rotation about the line y equal to 1 or line parallel to x-axis. So far we have discussed those type of problems in which we are considering rotation about either x-axis or y-axis, but here we are going to consider rotation about the line y equal to 1. First we understand what is this question about. Find the volume of the solid generated by revolving the plane region bounded by y equal to square root of x and the lines y equal to 1, x equal to 4 about the line y equal to 1. So here first we decide that these curves will intersect at which points. For example, if we consider y equal to 1 in y equal to square root of x, then we will obtain 1 equal to square root of x, that is x square equal to 1 and x equal to plus or minus 1. So y equal to 1 will intersect this parabola y equal to under root x at points 1, 1 and minus 1, comma 1. Similarly, if we take x equal to 4 in this equation, y will be equal to square root of 4 and there are two possibilities, plus or minus 2. So when x is 4, value of y is 2 and minus 2. Therefore, this x equal to 4 will intersect y equal to square root of x at these 2 points, 4, 2 and 4, minus 2. It is better to decide the points of intersection so that it will become easy to sketch the region bounded by these curves. So now we try to sketch the region bounded by given curves. So for that, suppose this is y-axis and this is x-axis. We will require the line y equal to 1 and x equal to 4. Suppose this distance is 1, then this is the line y equal to 1 about which we will rotate the given region, and we will also require the line x equal to 4 which is parallel to y-axis. So we consider this much distance as 4 and roughly we consider that this is the line x equal to 4, x equal to 4 and y equal to 1. This is x-axis and this is y-axis. This much distance is 1, here we have 0. We have taken this much distance as 4 and this is going to be 2. Now we require points 4, 2 and 1, 1. 4, 2 will be somewhere here. This is the point 4, 2. 4, minus 2 will be below this x-axis, but we will not require that point. We will require 4, 2 and 1, 1 only. So 1, 1 will be somewhere here. This much distance is 2. So this is 1. So this point is 1, 1. So now this parabola y equal to square root of x has this type of shape. We are familiar with the shape of this parabola y equal to square root of x or y square equal to x, but we require the portion which is bounded by these two lines and y equal to square root of x. So we will consider this part of the parabola between these 2 points y equal to 1, 1 and 4, 2. We will consider only this portion of the parabola. Okay, it will extend in this way and it will pass through origin and it will go in this direction, but for our region we will require only this part of the parabola which is y equal to square root of x. It is passing through 4, 2 and 1, 1. So you can see this is the plane region whose boundaries are, this is x equal to 4, this is y equal to 1 and this is the boundary of parabola. We are interested in the plane region bounded by y equal to square root of x equal to 4 and y equal to 1. So we have to rotate this plane region about the line y equal to 1. So here rotation is about the line y equal to 1. So as we know, to find out the solid generated by this plane region, we have to consider the mirror images of this y equal to square root of x about the line y equal to 1. So we can copy this. If we consider the mirror image of y equal to square root of x with respect to the line y equal to 1, then we will have this type of shape for the solid generated. It will look like this. The solid generated by rotating this plane region may look like this. Okay, we will require just a rough sketch. So I roughly sketch this solid generated by the given plane region about the line y equal to 1. So our solid will be in this form. Now we have to consider this volume of this solid. We are asked to find out volume of the solid generated by revolving the plane region. So this is the solid generated by this plane region. Now to find out the volume of this solid, we have to consider the cross section of this solid perpendicular to its axis of rotation. So if we consider this solid, if we consider the cross section of this solid perpendicular to axis of rotation, then we will obtain a disc, circular disc, which may look like this, and the thickness of this disc will be delta x, and the radius of this disc will be this distance. Because now our axis of rotation is y equal to 1, the center of this disc is on the line y equal to 1. Therefore the radius of the disc is distance between this y equal to square root of x and the line y equal to 1. So this distance is nothing but square root of x minus 1. So this will be the radius of the circular disc, which is the cross section of this solid perpendicular to the axis of rotation, which is y equal to 1. And thickness is delta x or dx. So once we decide the value of radius of the disc, we have ready-made formula for the volume of the solid. So using that formula, we can find out the volume of solid of revolution generated by revolving the plane region about the line y equal to 1. Now the volume is given by pi into square of radius function rx square. Integral is with respect to x, and the limits of integration will be values of x. We start from this value of x, we start from this point and we go up to this point. At this point value of x is 1, at this point value of x is 4. Therefore limits of integration are from x equal to 1 to x equal to 4. Now this is simple problem of integration. We can take pi outside integral, it is independent of x. Rx is square root of x minus 1 whole square. Integral is with respect to x. So to integrate we have to expand this integral from 1 to 4. Square root of x is x minus 2 times square root of x plus 1. Okay, we are using the formula of square of a minus b, a square minus 2ab plus 1. Now we apply the power rule and we integrate. Integral of x is x square by 2 minus 2 square root of x means x raised to 1 by 2. Integral of x raised to 1 by 2 is x raised to 1 by 2 plus 1, that is 3 by 2 divided by 3 by 2, and integral of 1 with respect to x is x. Limits of integration are from 1 to 4. So now we consider we can rewrite this second term. We consider this 3 by 2 in the numerator. Reciprocal of 3 by 2 is 2 by 3. So we have 4 by 3 times x raised to 3 by 2 plus x. Integral has limits from 1 to 4. Now we consider upper limit minus lower limit. First we take x equal to 4. So x square means 16 divided by 2, which is 8, minus 4 by 3, x equal to 4 raised to 3 by 2 plus 4. This is for upper limit for x equal to 1, minus for x equal to 4 we obtain these terms. For x equal to 1 we have 1 by 2 minus 4 by 3 plus 1. Now this 4 raised to 3 by 2 we can simplify in this way. 4 that we can rewrite as 2 square raised to 3 by 2. 2 will cancel out and we have 2 raised to 3, that is 8. So this quantity is 8, and 8 into 4, that is 32 by 3. So we can rewrite this as 8 minus 32 by 3 plus 4, and we can take negative side inside the bracket, and we have minus 1/2 plus 4 by 3 minus 1. Now we combine this 8 plus 4, 12 minus 1, that is 11. Similarly we can combine these two. We have LCM as 3, and minus 32 plus 4, that is 28 by 3, and this minus 1/2. Now again we can take 6 LCM. So pi as it is, here we have 6. 11 is multiplied with 6, that is 66. Here 2 is missing, so we multiply 28 by 2 and we have 56, and here we have to multiply by 3. So we have 66 minus 56, that is 10, and 10 minus 3 is 7. So we have pi into 7 by 6, or we can rewrite this as 7 pi divided by 6. So in this way we can obtain the volume of solid of revolution generated about the line y equal to 1, which is different from x axis and y axis.